Gases and absolute scales of the temperature. So first of all, we have to see the relationship between the pressure and the temperature at constant volume. If we keep the volume of the gas constant, what would be the relation between the pressure and the temperature? So remember that for fixed mass of the gas, the pressure and temperature, both of these are directly proportional to each other by keeping the volume constant. I write here pressure is directly proportional to temperature. When the volume is constant, you don't need to change the volume. For a fixed mass of the gas, the pressure of the gas is directly proportional to the temperature at the constant volume. This is a relationship between the pressure and the temperature when the volume is kept constant. So there is a sign of proportionality, this one. When you want to remove this sign of proportionality and replace it with the equality, there should be some constant. So I write here P is equals to K, where K is any constant and here is temperature T. If I write this relation for the two gases, for the first gas P1 is equals to K T1 because K is a constant. For the second gas P2 is equals to K T2. I find out the value of K from both of these equations. K is equals to P1 over T1 and from here K is equals to P2 over T2. Now you need to equalize both of these equations because on the left hand side there is a constant K. So I can simply write here P1 over T1 is equals to P2 over T2. For any two gases, when the initial pressure and the temperature is given and the final pressure is given, you need to find out the final temperature. You can use easily this formula. This formula is basically used when the volume is constant and you need to relate the pressure with the temperature. Here P1 is the initial pressure, P2 is the final pressure. T1 is the initial temperature and T2 is the final temperature. So if any one of these parameters is unknown, you can easily calculate by rearranging this equation. But just remember that this relation is applicable at the constant volume. You can see here the mathematical form. Pressure is directly proportional to the temperature. And when you have to remove the sign of proportionality, this one, you have to replace it with the equality. That I do here. You need to put here the constant which I represent with K. After that, for any two system means that for any two gases, this equation can be written as P1 over T1 is equals to P2 over T2. This equation is valid only at the constant volume when the pressure and temperature is given. So this is a relation between the pressure and the temperature at the constant volume. Here is the explanation for this relation. How you can explain that by increasing the pressure, the temperature also increase because both of these are directly proportional to each other. So I simply consider here, I take any system that contains the gas particles. So this is the gas that is filled in the container. What will happen? I increase the temperature of this gas. Now I am going to increase the temperature of this gas by supplying the heat. When I supply the heat, the temperature of the gas molecule rises and they move very quickly. You know that there is a large spacing between the molecules of the gas and they can move in all directions. So by increasing the temperature, the molecules move very quickly, and you know that temperature and average kinetic energy, both of these are directly proportional to each other. By increasing the temperature, the average kinetic energy of the gas particle increase. And kinetic energy is basically related with the speed of the particle, means that 1 over 2 mv square. So when the average kinetic energy increase, accordingly the speed of the moving particle increase. So I can simply say that by heating the gas, the temperature increases, due to which the particle moves very quickly. and by increasing the temperature, the speed of the particle increases. The same thing is given here. When the temperature rises, the molecules move more quickly. We know that the average kinetic energy depends upon the speed. Therefore, by increasing the temperature, the kinetic energy of the molecules increases, but the volume remains constant. There is no change in the volume. Only by increasing the temperature, the average kinetic energy of the particles increase. Because both of these are directly proportional to each other, higher the temperature, higher would be the average kinetic energy possessed by the molecules. Smaller the temperature, smaller will be the kinetic energy possessed by its particle. Now what will happen when the temperature is increased? So when you supply here the heat, the temperature of the gas increase. The molecules of the gas move very quickly. They collide with each other and also with the wall of the container, and they also rebound back. So when they rebound back, they actually change their direction. Means that the direction of the motion of the particle changes. It means that there would be the change in velocity due to which the change in momentum take place. And you know that applied force F is equals to delta P over delta T, where P is here momentum. So change in momentum per unit change in time is basically equals to force. It means that when there is change in momentum, the particle exert a force on the walls of the container. And you also know that pressure is equals to force per unit area. When the particle exert the force, there would be the pressure exerted by the gas molecules. So I can simply say that when you supply the heat, the temperature increase, and by increasing the temperature, the pressure of the gas also increase. So both of these are directly proportional to each other. All of these things happens at the constant volume. When the volume of the gas does not change, it remains constant. Then by heating the gas, the temperature increases, due to which the pressure also increase. Because both of these are directly proportional to each other at the constant volume. You can see here, higher the temperature of the gas, the larger would be the average kinetic energy possessed by its molecule. The molecules will move more quickly as the gas heats up. Means that by increasing the temperature, the molecules moves very quickly. They collide with the wall of the container more frequently, causing the pressure to increase. So I can simply say that by increasing the temperature, the pressure of the gas increase, and by decreasing the temperature, the pressure of the gas decrease. Both of these are directly proportional to each other. Here you can see the relation between the pressure and temperature. As both of these are directly proportional to each other, there is a straight line that is rising in upward direction. Here is a simulation which is relating the temperature with the pressure at constant volume graphically. Let's open this. I'm heating this system. Means that I'm going to increase the temperature. You will see that the particles start moving very quickly inside this container. Means that their speed increase and their collision with the wall also increase. Due to increase the collision with the wall, actually the pressure increases, and you get a straight line on the pressure temperature graph at the constant volume. You can observe this curve by heating the system. You can see here again the motion of the particles. These are moving very frequently because you are heating the system, due to which the pressure increase, and you get a straight line on the temperature pressure graph by keeping the volume constant. You can also practice it from your account. Let's go back. Next is the Wiles law. This law is basically used to describe the relationship between the pressure and volume at the constant temperature. When the temperature of the gas does not change, What would be the relationship between the pressure and volume? It is given by the Boyle's law. According to the Boyle's law, we can simply say for a given mass of the gas, the applied pressure is inversely proportional to the volume by keeping the temperature constant. I write here, pressure is inversely proportional to the volume by keeping the temperature constant. The temperature should be constant, it does not change. So when both of these are inversely proportional to each other, what does this mean? It means that when you increase the pressure, the volume decrease. And by increasing the volume, pressure decrease. Both of these vary inversely to each other. By increasing the one quantity, the second quantity increase, and by decreasing the first quantity, the second has to increase. But the condition is that the temperature has to remain constant. At the constant temperature for the fixed mass of the gas, the pressure is inversely proportional to the volume. You can also see here, it gives the relationship between the pressure and the volume at the constant temperature. Therefore, according to the Boyle's law, for the fixed mass of the gas, the applied pressure is inversely proportional to the volume at the constant temperature. The temperature has to be remain constant. At the constant temperature, the pressure is inversely proportional to the volume. See this equation, if I have to remove this sign of proportionality, I have to replace it with the equality sign. So I need to put here some constant. I write P is equals to some constant which is K divided by V, where K is constant here, which is the proportionality constant. I write this equation like K is equals to PV. What does this mean? PV is equals to constant. According to the Boyle's law, the product of the pressure and volume is constant. Like it is equals to some constant value, it does not change. So if I write this equation for the two systems, for two gases, I write here K is equals to P1V1. And for the second system, K is equals to P2V2. As K is a constant here, left hand side is equals to K. So you can equate the right hand side and can write here P1V1 is equals to P2V2. And this relation is only hold when the temperature is constant. The temperature does not change. So I can simply say from here, the pressure is inversely proportional to the volume at the constant temperature. And P1V1 is equals to P2V2 is basically the relation that I derived for two gases or the two systems. So if I suppose that the initial pressure and initial volume is given, the final pressure is also given, you need to find out the final volume. Then you can rearrange this equation according to the unknown variable. You want to find out V2. It would be equals to P1V1 over P2. So you just need to rearrange this equation according to the unknown parameter. You can easily find its value. But the condition is that the temperature has to be remain constant. Here is the experimental arrangement and procedure for verifying the Boyle's law. In this figure, you can see it's the experimental arrangement for the Boyle's law. There is a scale which you can see here, this scale, where I also calibrate this scale. It is basically showing the volume of the trapped air in the glass tube. You can pump the air from here. The air is pumped into the area above the oil reservoir, using the foot pump to change the pressure. When you pump the air, then this causes the increase in the pressure of the air inside the glass tube. And here is a pressure gauge that is used to measure the pressure. You can easily measure the pressure with the help of pressure gauge. By measuring the values of the pressure, you can also note the corresponding values of the volume. Because here this scale is used to find out the volume of the trapped air in the glass tube. When the pressure is changing, accordingly the volume also change. So you can easily find out the volume by the calibration on the scale. The scale behind shows the volume V of the trapped air in the glass tube. Air is pumped into the area above the oil reservoir using a foot pump to change the pressure. So basically you have to use here the foot pump so that the air is pumped into the area above the reservoir and you can easily change the pressure. This causes the increase in pressure of the air inside the glass tube. The pressure gauge is used to measure the pressure of the fixed mass of the gas at the constant temperature. You know that it's the boiler and here the temperature is constant. So the pressure gauge is used to measure the pressure of the fixed mass of the gas, but the temperature has to be constant. Accordingly, you have to find out the value of the volume corresponding to the values of the pressure by using the scale. When you find out the values of the pressure and volume, you just need to draw the graph between them. What is the result of this experiment? The result is given here. For any fixed mass of the gas, when you increase the pressure, the volume decreases because you know that the pressure and volume, both of these are inversely proportional to each other. I write here P is inversely proportional to the volume when the temperature is constant. So when you increase the pressure, accordingly the volume decreases. If I say that the volume of the gas is double, what would be the effect on the pressure of the gas by keeping the temperature constant? So see here the volume gets double. It means that volume becomes 2V. Then what would be the effect on the pressure? You know that by increasing the volume, the pressure decreases because both of these are inversely proportional to each other. So you can simply say that the pressure becomes half by doubling the volume. So here the pressure becomes half. New pressure is half of the original pressure because here you double the volume. Keep the temperature constant, accordingly the pressure becomes half. So I can simply say that the pressure and volume, both of these are inversely proportional to each other. And according to the same relation, like I told you, the pressure is inversely proportional to the volume. When you remove this sign of proportionality, here would be some constant P is equals to K over V. From here, K is equals to PV. By this relation, you can simply say the product of the pressure and volume has the constant value. It does not change. After that, you can write the same equation for the two systems and you get the relation that the product of the pressure and volume does not change. That's why P1V1 is equals to P2V2. Both of these sides are equal. It means that if any one of the parameter is unknown and all other are known, you can easily find out the unknown parameter by rearranging this equation. But the condition is here that temperature has to be constant. It does not change. So I can simply say here for the fixed mass of the gas at the constant temperature, the pressure and volume, both of these are inversely proportional to each other. You can see here the results. When the pressure of the fixed mass of gas rises, the volume of the gas decreases. The fact is that the volume of the gas gets double when the pressure is reduced by half. When you reduce the pressure by half, the volume gets double because both of these are inversely proportional to each other. Demonstrates that the variation of the applied pressure and volume are inversely proportional to each other. The product of the pressure and volume has the constant value. Therefore, applied pressure is inversely proportional to the volume at the constant temperature for the fixed mass of the gas. Here you can see the relationship between the volume and the pressure at constant temperature. As both of these are inversely proportional to each other, therefore you get this curve on the volume pressure graph. Here is the explanation of the graph. You can see here According to the graph, when the pressure of the fixed mass of gas rises, the volume of the gas decreases, so that the product of the pressure and volumes remains constant when the pressure is plotted against the inverse volume. What is meant by this? Initially, we see the graph between the pressure and volume on the previous slide. You can see here the graph between the volume and the pressure, and it's a curved. Now we have to draw the graph between the inverse of the volume and the pressure. Then what will happen? Let me make here the axis. Here is the pressure and here is inverse volume. You know that according to the Wahl's law, the pressure and volume, both of these are inversely proportional to each other. If I only talk about the inverse of the volume, which is 1 over V, or it is also be V power minus 1. Both of these are the inverse volume. So, if the first term is pressure here, and the second term is 1 over V. According to the Wahl's law, the pressure is directly proportional to the inverse of the volume. See again this relation. On the left hand side here is pressure and on the right hand side here is the inverse volume. So both of these are directly proportional to each other. When the pressure and inverse volume are directly proportional to each other, you get a straight line on the graph, just like that. The same thing is given here. When pressure of the gas is plotted against the inverse volume, then graph will be a straight line passing through the origin, indicating that the applied pressure and inverse volume varies directly proportional to each other. So this straight line showing that the pressure and inverse volume, both of these are directly proportional to each other. Here is the examination tips. As directly proportional graph between the two quantities is a straight line, when you draw the graph between two quantities and the relation between both of these is directly, means that by increasing the one quantity, the other also increase. It is just like the relation between the temperature and the pressure and the constant volume. Like the pressure and temperature, both of these are directly proportional to each other at the constant volume. Then you get a straight line on the graph starting from the origin and it's rising upward. The same thing is given here, as the directly proportional graph between the two quantities is a straight line starting from the origin and sloping upwards. Let me draw this one. It is just like that. The curve starts from the origin and then sloping upward. So you may make mistake here for inversely proportional graph. You may think that it also be a straight line graph sloping in downward direction, but it's not true. The inversely proportional graph is the same as is shown by the curve on the Wahl's law. That is the relation between the pressure and the volume at the constant temperature. Here is a curved path. So this curve is basically showing the inverse relationship between the pressure and the volume. Let me draw here. Here is pressure and here is volume. You get a curve like that. This curve is basically showing the inverse relation between the pressure and volume. But if there is a direct relationship between two quantities, then you get a straight line that is passing through the origin. You cannot say that if it's an inverse relation, then it might be a straight line that is sloping in downward direction. It's not true. You can see here is a simulation that is related to the Wahl's law. Let's open this. So let's start this. First of all, I pause the system. Now I'm going to start it. Here I'm going to decrease the volume. You can see here this piston is moving in downward direction, means that the volume is decreasing. By decreasing the volume, the pressure increases because both of these are inversely proportional to each other. Then you get a curved graph for the pressure and volume, which is for the Wiles law. This graph is basically showing the relation between the pressure and volume when the temperature is constant. As both of these are inversely proportional to each other, that's why you get here a curve on the pressure volume graph. You can also practice this as well. It's present in your account. Here is also again the simulation related to the Wiles law. Let's open this. Here you can see the particles are moving in any random direction. Now if I suppose that initially the volume is 3.0 liter, I'm going to decrease the volume. Then what will happen? You can see the collision between the particles become frequently. The collision increase by decreasing the volume. It means that pressure increase by decreasing the volume. You can also observe here you get a curved path on the pressure volume graph. Now if I suppose that I'm going to increase the volume, then what will happen? The collision become very small, means that pressure decrease because both of these are inversely proportional to each other. By increasing the pressure, the volume decrease. But the condition is that here the temperature has to remain constant. The temperature does not change. This is the relationship between the pressure and the volume at the constant temperature, and you get a curve on the pressure volume graph. Let's go back. Here is the exam question that appeared in October-November 2016. The diagram shows a gas that is trapped in a cylinder by a piston. The volume of the gas is 120 cubic centimeter and the pressure of the gas is P. The piston is moved slowly to the left. Now you are going to move the piston towards the left so that the gas is compressed. So that the volume of the gas is reduced to 30 cubic centimeter. The temperature of the gas does not change. What is the new pressure of the trapped gas? So first of all, the major point here, the temperature of the gas does not change. It means that the temperature remains the same. So when the temperature remains constant, what is the relationship between the pressure and the volume of the gas? It is given by the Wiles law. Because here you can see the initial volume of the gas is given, which is 120 cubic centimeter, and the final volume is 30 cubic centimeter. The initial pressure of the gas is P. What would be the new pressure of the gas when the volume becomes 30 cubic centimeter from 120 cubic centimeter? So here this question is relating the pressure with the volume at the constant temperature. It means that here you need to use the Wiles law. Let's see the answer and explanation. You can see here initial volume is given, which is 120 cubic centimeter. Final volume is equals to V2. It's 30 cubic centimeter. Initial pressure is P1. It is equals to P because the initial pressure of the gas is equals to P. You need to find out the final pressure of the gas when the temperature is constant. If the temperature is constant, it means that T1 is equals to T2. The temperature is not changing. I can simply write T1 is equals to T2. Initial temperature of the gas is equals to final temperature, and both of these are equal. It means that the temperature is constant. According to the Wiles law, you know that the product of the pressure and volume is constant. That's why P1 V1 is equals to P2 V2. Then rearrange this formula and make the P2 as a subject. You get P2 is equals to P1 V1 over V2. Just put here value P1 is equals to P. V1 is 120 cubic centimeter and V2 is 30 cubic centimeter. You get that P2 comes to be 4P. It means that the new pressure P2 is equals to 4 times the initial pressure P. Hence, D answer is correct. Scales of temperature. How many scales of temperature are there? There are basically the two scales of the temperature. We can measure the temperature in two units. One is the Celsius scale and the second is Kelvin scale. Both of these scales are used for the measurement of the temperature. First of all, we see the Celsius scale and then the Kelvin scale. The Celsius scale basically starts from the 0 degrees C and it ends at 100 degrees C. The smallest temperature on the Celsius scale is 0 degrees C and the maximum temperature is 100 degrees C. There are total 100 divisions on the Celsius scale. But the Kelvin scale starts from the minimum temperature, which is minus 273 degrees C, and it ends at minus 373 degrees C. The Kelvin scale starts from 0 Kelvin and it ends at 100 Kelvin. Now the second thing that I write here, for the Kelvin scale, it starts from minus 273 degrees C and ends at minus 373 degrees C. Both of these are basically for the Kelvin scale. There is a relation between the Celsius scale and the Kelvin scale. If the temperature is given in Celsius scale, you can easily convert into Kelvin. And if the temperature is given into Kelvin, you can easily convert into Celsius. So the same thing is given here. The Kelvin temperature scale begins at absolute 0. The 0 Kelvin temperature is basically called as absolute 0 and it is equals to minus 273 degrees C. So I can simply write here 0 Kelvin is equals to minus 273 degrees C. Both of these are equal. Means that if you consider 0 Kelvin, its value in the Celsius scale is minus 273 degrees C. Both of these are equal and it is the lowest possible temperature. 0 Kelvin is the lowest possible temperature and it is equals to minus 273 degrees C. How we can make the conversion of Celsius into Kelvin and Kelvin into Celsius? We will also see it. So first of all, here you can see, to convert the temperature between the Celsius and the Kelvin scale, make the following conversion. You need to make the following conversion. This is just like the temperature in Kelvin is equals to temperature in degrees C plus 273. When the temperature is given in degrees C and you want to convert this temperature into Kelvin, then you just need to add a factor 273 into the value of the temperature in degrees C. If I suppose that you are given in the degree C, the temperature is 2 degrees C. What is its value in the Kelvin? How many Kelvins are there in 2 degrees C temperature? So how you can make this conversion? First of all, use this formula that I write here. Just put here the temperature in the degree C, which is 2 plus 273. It would equals to 275. No, this temperature is basically comes in Kelvin because here you add the factor of 273. This would be the temperature in Kelvin. So I can simply say that when you want to change the degree Celsius into Kelvin scale, then just add 273. That I do here. Here the temperature is 2 degrees C and I want to convert into Kelvin. I add 273 into this temperature is converted into Kelvin scale. After that, I suppose you are given the temperature which is 0 Kelvin. Then how many degrees C are there in 0 Kelvin? So first of all, you need to rearrange the conversion formula. I write here as you find out the temperature in degree C. Then make the degree C as a subject. I write here temperature in degree C is equals to temperature in Kelvin minus 273. Now the temperature in Kelvin is given, which is 0 Kelvin. Just put here 0 minus 273. You get the temperature minus 273 degrees C. It means that 0 Kelvin is equals to minus 273 degrees C. So see here, when I want to make the conversion from Kelvin to Celsius scale, I subtract minus 273 from the given temperature value. But if the temperature is given into degrees C and you want to convert into Kelvin, then you have to add a factor of 273 into the given temperature value. So the same thing is given here. Temperature in Kelvin is equals to temperature in degrees C plus 273. There is also a very important point. An increase of 1 Kelvin is the same change as an increase in 1 degree C. If you increase the temperature of 1 Kelvin, it is same as you are increasing the temperature by 1 degree C. Because in both of these scale, there are total 100 division. Because here in the degree C, you can see it starts from the 0 degree C and end at the 100 degree C. It basically divided into 100 equal parts. Similar to the Kelvin scale, here it starts from 0 Kelvin and ends at 100 Kelvin. There are total 100 parts in the Kelvin scale. That's why I can simply say that when you increase the temperature by 1 Kelvin, it is basically the same as you are increasing the temperature by 1 degree C. Then there are some questions for you. How many degrees are there in 27 Kelvin? You have to find out the temperature in degree C when the Kelvin temperature is 27 Kelvin. After that, how many Kelvins are in 273 degrees C? You also have to find out how many Kelvins are there in 273 degrees C. Here is the example question. Make the following conversion. First of all, temperature is 30 Kelvin and you need to convert this temperature into degree C. I told you the simple trick that when you are going to convert the temperature from Kelvin into degree Celsius, then in this way you can subtract 273 from the given temperature. So here I can simply write temperature in Kelvin is equals to temperature in degree C plus 273. You have to convert into degree C, then make the Celsius scale as a subject. It would be equals to temperature in Kelvin minus 273. Now see the value of the temperature in Kelvin. It is 30 Kelvin. Put here 30 minus 273. It is basically equals to minus 243 degrees C. So this is the temperature in degree C when 30 Kelvins are given. So I write here minus 243 degrees C. In the second question, the temperature in the degree C is given and you need to convert into Kelvin. You can do it on the same pattern, but instead of making the degree C as a subject, here you make the Kelvin as a subject and put the value of the temperature in degree C. Find out the corresponding values of the temperature in Kelvin. Let's see the answer and explanation. The relation between the Kelvin and Celsius scale is given. Temperature in Kelvin is equals to temperature in degree C plus 273. In the first part, the temperature is 30 Kelvin. Then use the formula, you get the temperature in degree C, which is equals to minus 243 degrees C. When the temperature is equals to 45 degrees, then you have to make the same formula, but in this case, make the Kelvin as a subject. Then put here value, you get 318 Kelvin. It means that 45 degrees C is equals to 318 Kelvin. Here are some questions for your practice. Question number 1. A bubble of the air has a volume of 2.0 cubic centimeter at the bottom of the lake, where the total pressure is 4.5 times 10 to the power 5 Pascal. The temperature of the water in the lake is constant. You can see here the temperature remains constant. The atmospheric pressure at the surface is 1.0 times 10 to the power 5 Pascal. What is the volume of the bubble when it rises to the surface? So basically the initial volume is given, initial pressure is given, final pressure is given, and you need to find out the final volume when the temperature is constant. First of all, you have to guess that which relation you can use here, and accordingly you can find out the volume. Question number 2. A gas has initial pressure of 6.4 Pascal and initial volume of 8.0 cubic centimeter. What is the new pressure of the gas if its volume decreased to 3 cubic centimeter, assuming that its temperature does not change? So here again the temperature is constant, initial pressure and volume is given. You need to find out the new pressure if the new volume is given. Question number 3. How many kelvins are in 0 degree C and 69 degree C? Question number 4. How many Celsius are in 253 Kelvin and 89 Kelvin? So in the question number 3 and 4, you just need to make the conversion of the temperature. In the question number 3, the temperature is given in degree C and you need to convert into Kelvin. And in question number 4, the temperature is given in Kelvin. You need to convert this temperature into degree C. Today's lesson is ending. If you find any difficulty, you can ask. Thank you.